Welcome, everyone. We are broadcasting from the Glencoe Public Library, and tonight we have three presenters with us who are going to talk about Glencoe's water and your new water meters. And I'm going to, we're going to start with Pete Mulvaney. He's going to, and then he's going to talk a bit and then introduce our other speakers, who are Alex Urbanchik and David Mao. Pete is a Village of Glencoe trustee and a member of the Sustainability Task Force of Glencoe, and he's also a water resource engineer. Thank you, Pete, and thank you, Alex and Dave, for being here.
Okay, is that me?
You're up.
Ready to go? Great. I'm going to share my screen here and open up a presentation. And while that's coming up, I would like to first off acknowledge today is Veterans Day. So for any veterans out there, thank you very much for your service. Today for this talk, as Grace said, we'll be discussing the different water systems of Glencoe. And I'll try and present initially a big picture of our different systems on the drainage side. The sanitary system, the notion of a watershed, and stormwater management, and then pass it to Dave and Alex for a discussion around potable water. So one of the key messages we hope to get across here is the different types of systems, that we've got different pieces of infrastructure, serves different purposes, and the Village of Glencoe is responsible for these systems and their ultimate service to the community. So starting with drainage, let's see if I can get rid of this image here, these pictures. Starting with drainage, what I'd like to get across is where our water goes. So not everybody knows what happens to our stormwater or what happens to the water that comes out of our shower, and once it goes down that drain, what happens to it? Where does it end up? How is it treated? Meaning, you know, we need to treat it before we drink it. We need to treat it before we return it to nature. And why is this so important? Why should we be carrying and investing a good portion of Glencoe's budget goes to managing our water systems? And as I think you'll hear later in the presentation, we still have more investments to make in our various water systems to keep them modernized and to keep them working optimally. So I'm going to jump right in here. I have a pretty quick story to tell in each of these systems to try and just present a bit of a bigger picture so we understand really how Glencoe fits into the larger context. Some of you may have participated in a library talk a month or two ago regarding the Great Lakes. And of course, we are adjacent to the Great Lakes, and Lake Michigan serves us, is our source water, which provides the water that we use in our homes, right? So the sanitary system, the sanitary side is the drain, and that's draining your toilets, your sinks, your showers, you name it. If it's coming out of your faucet, that water from the home is going to be connected to the sanitary system, not the stormwater. We don't want our stormwater in this system. It's just about the water use associated with your home. And the sanitary system in Glencoe connects every one of your homes to a larger system, right? That larger system is run by MWRD, the Metropolitan Water Reclamation District. And they have pipes that connect to ours, which carries that sanitary flow down to the North Shore Channel. The North Shore Channel, the North, I should say here, the wastewater treatment plant is at Howard and McCormick, located on the North Shore Channel, and our wastewater is treated at that facility and discharged into the channel. And then from there, the water flows south, and I'd like to be able to show you, I'm hoping this will work. What I want to show you very briefly is just map that out for you. And I have a somewhat ugly image from Google Earth, but what I think I can do here, if things are working properly, is highlight where Glencoe is on this image. So Glencoe's up here in the northern end of this image here. And if you look here, the the collection system, the sanitary sewers of Glencoe collect all this water and they pass it on to MWRD, which has pipes. So our sanitary flow is carried in pipes down to about here where the North Plant Water Reclamation Facility is. If you look closely, I'll try to highlight it. If you look closely, this is the North Shore Channel right here. You're probably familiar with the North Shore Channel. Just to get your bearings, this is the Baha'i Temple, right? This is Montrose Beach. This is downtown Chicago. This is O'Hare, just to help you get your bearings. This green swath is the Des Plaines River. This green swath is the Skokie Lagoons, and down the Skokie River, the north branch of the river, and down into Chicago. So our sanitary flows that come out of your homes, of course, the supply waters comes from Lake Michigan into your homes through your faucets. It all gets piped and flowed in a few pumps to bring it down to the treatment plant, discharges that water into the North Shore Channel. The North Shore Channel, if anybody's familiar with River Park in the city of Chicago, it's right here, the confluence of the North Shore Channel and the North Branch. And believe it or not, our flows continue on south, right past through Chicago, past the main branch of the Chicago River, past Bubbly Creek, Ship and Sanitary Canal, and on south. Who knows what happens from here? Where does our water go? Every time you turn on your faucet, you're creating part of this flow. And where does it go? Well, believe it or not, it goes from here, it connects onto the Des Plaines River, the Illinois River, the Mississippi River, and into the Gulf of Mexico. So despite the fact that we are adjacent to the Great Lakes, when we pull water out of it, it is not returned. It flows out south to the Gulf of Mexico. It's across a major subcontinental watershed divide. So this is really what I want to emphasize with respect to our sanitary sewer system and give you some perspective. What you really want to know is that we are moving, when we use water, we're moving it from the lake down through this larger drainage system out to the Gulf of Mexico. And if you ever want to go visit your wastewater, you can go find it at the North Plant Wastewater Treatment Plant. This is an aerial image of the plant that treats our wastewater. Everything that comes out of your homes is treated here, discharged to the channel, and sent south on the journey I just mentioned. I'm not going to talk about here at this point the details of the Glencoe sanitary sewer system. I thought for this presentation we would just keep it to the high level of the sanitary system purpose is to collect those flows from your home and move it on to treatment through the agencies and assets of MWRD. I would suggest though, and I'm going to put Dave Mao on the spot, if there are questions when we're finished here, I think that we could get into some of those details if people are curious about how many miles of water there are, how many miles of sewers there are, and that sort of thing. So with that, I'd love to shift the conversation and shift your mindset here. We need a bit of a break of what we're thinking about and shift our thinking to stormwater. Stormwater is not coming from the lake, it's coming from the sky, right? And when we think about stormwater, we should be thinking about watersheds. Not everyone knows what a watershed is, but I think of it as a natural boundary. Watersheds are defined by topography, and that topography decides which way rainfall will flow when it hits the ground, right? So let me think of an example. The Ridge Avenue in Evanston, if you've ever driven down Ridge Avenue, is called Ridge Avenue because it's a high point. It was also used to be a Native American trail. They also like to walk in the highlands, right, to keep their feet wet. So they were, if you're driving down on Ridge Avenue and you look to the left and you look to the right, you'll see that there's a flow that you're sloping down on either side. You slope either to the lake or west from Ridge Avenue. And rain follows that slope. So rainfall on the east side of Ridge Avenue is going to go down to the lake, and the west side, it goes down to the drainage system I just described. So here in Glencoe, our village is split in essentially two roughly equally sized areas through a natural boundary of our watershed boundary. And to the east, it goes to Lake Michigan. To the west, we're going to the Skokie Lagoon, actually a ditch that surrounds the Skokie Lagoons. And then that goes on to the Skokie River. And I'm going to try and map for you those same ideas so you get this perspective. What you're looking at here is a map provided by the village, which defines the separation, the natural boundary within Glencoe. And it's really fun to try and find your home where you live and understand which journey your stormwater is going to take. Is it going to go to the lakes, or is it going to go past the Skokie Lagoons? So, and you can also see a very important feature here on this image. You see these dark brown lines. This is a topography. And when you see these darker areas, this is where you have a steeper slope. This is a ravine system. Glencoe is on the southern portion of a Lake Michigan ravine system. And these are really important to understand from a stormwater perspective. Remember, a watershed is the land area that drains to a water body. And these ravines are our natural ways and flow paths for our stormwater. So these ravines reach up into Glencoe, and stormwater that lands on the right-hand side of this red line makes its way through one of these ravines and out to Lake Michigan. Conversely, on the west side, stormwater that's landing over here is ultimately going to make its way towards the Skokie Lagoons through a ditch. And I think I can show you what's different about our stormwater. Whereas our sanitary system was going here to the North Shore Channel, our stormwater, on the other hand, makes its way to the Skokie Lagoons, which is here, throws the Skokie River, the north branch of the Chicago River, and here, and makes its way south, right? So a slightly different path than our sanitary flows. And you'll note there is not treatment of our stormwater. Okay, so our stormwater that runs into off of our lands, that stormwater is not treated. And so whatever it picks up, it makes its way straight into our environment. So let me come back. So very important idea. I think it's fun for everybody to take a moment and see if you can identify which side of the watershed you're on. That should give you some mental reference as to where we are going with our water. We talked about going to the west is a very similar path as our sanitary, but not exactly. And I want to emphasize, why is this important? Why do we want to have a sense of where our water goes? Well, first off, the stormwater lands, it's everywhere, right? It's on your rooftops, it's in your yards, it's in your driveway, it's on our roadways. And as I just mentioned, whatever that lands on, the water will pick it up and carry that possible pollutant into the waterways. So this could be fertilizer on our yards. It could be pesticides, herbicides. It could be the salt from our roads that we use in the wintertime. And it's carrying that water to, in the case of the Skokie Lagoons, a place where you may fish, you may boat, and certainly I hope that everybody takes advantage and enjoys the natural beauty of the Skokie Lagoons, which is often eroded because you'll see, many of you may have noticed, a lot of algae growth, especially in the late summer and fall. Well, that's a direct impact of excess fertilizers making it into our waterways, which stimulates the growth of algae. So it has a very direct impact on the quality of life in our environment in our immediate area. For water going to the east, Well, of course, we may be swimming there. We may be sailing there, fishing, playing, but it's also where we get our drinking water, as we mentioned at the beginning. The pollutants that run off from our roads and our homes can directly affect the quality of our beach experience and the quality of our drinking water. And this is a quick high-level overview, but I wanted to just lay that framework out so that you have some perspective as to where our water is going, why it's important to be aware of it. And before I flip it to Dave and Alex, I do have one more slide. Whoops, I think I covered that. One more slide of simple things that you can do to help reduce some of that pollutant load. Number one, as I mentioned, we can use less fertilizer, pesticides, and herbicides because you may ultimately end up drinking them. That will be very low concentrations. I'm not trying to give any kind of dire warnings here, but we can hear about we're going to hear in a moment about the potable water treatment to help remove any of those pollutants. But you can talk to your landscaper and encourage more sustainable landscape approaches. You could also contact anybody on the Glencoe Sustainability Task Force, and we'd be happy to help provide advice as to how to have more healthier, sustainable landscapes. We could also, as a community, support the use of salt alternatives for de-icing. Salt is a difficult pollutant. It's one that's hard to treat. It's hard to remove salts once it's in the water and once it's dissolved in water. You could also build a rain garden in your home. A rain garden is a relatively simple landscape modification to help capture stormwater runoff, typically from your roof. And what it'll do is that first flow of water off your roof can enter the rain garden, enter the soil, and filter some of those pollutants that land on your roof. There's a fair bit of pollutants that are deposited through air pollution. Things like driving our cars creates a number of different pathways for pollution to be airborne, which later just lands back on our surfaces and later washed away with rainfall. So more walking, biking, and scooting instead of driving. That will reduce the rubber and some of the metals that come off of our tires as we drive, and it obviously reduces some of the tailpipe emissions that ultimately land on our surfaces. A quick side note, most of the mercury in Lake Michigan is actually mercury deposits from coal-fired plants in China. The mercury from Chinese power plants have been traced straight to our Great Lakes. And you can also clean up after your pets, right? So leaving pet waste in the curb and gutter, depending upon what side of that watershed you live, will ultimately make its way to the lake or to the past the lagoons through the Skokie Ditch and down the Skokie River. Untreated, right? So remember, big difference in our systems here. The sanitary sewers, the things that come out of your home, are treated by MWRD, but our stormwater does not have any sort of mechanical treatment. Now, Dave, I don't know if you might touch on, if you want to touch on, there are some green infrastructure treatments that can be done on the outfall pipes, and Glencoe has been a pioneer on some of this and received some grant funding to do some treatment of our stormwater before it leaves our system into the lake. So with that, I will, I think, ask Alex to take the screen and let's pick up the conversation, I think, from Lake Michigan as our source of potable water and how we're managing our water system. I'm sorry, Alex or David.
Thanks,
So
Pete.
while Alex is pulling up that slide deck, I just wanted to thank the Sustainability Task Force for inviting us to join the conversation tonight. We welcome the opportunity anytime to be able to talk about our water infrastructure. So tonight, Alex Urbanczyk, who's our water plant superintendent, and I are going to walk through at a fairly high level the four major components to our water system, and then end up talking about the water meters, which is an initiative that's underway today as we speak. Those four components, major components, are obviously the water plant, but then also water storage. We'll talk a little bit about water storage and why that's important. Our water distribution system, which we produce it at the plant and then we distribute it out to all our customers through our water distribution system. And then lastly, the point of contact between our distribution system and you, the consumer, is the water meter at each of our single family residences and our businesses and apartments that are in town. So with that, Alex is gonna kick off our initial conversation, talk a little bit about the water plant.
Thanks, Dave. So here's the water plant in 1932. It was originally constructed. It was built in 1928 with a 3 million gallon per day capacity. In 1952, it was expanded to 8 million gallon per day capacity. And here's an aerial photo of the plant from 2017. Until 1963, the village used to supply the village of Northbrook with water until they constructed their own water treatment plant inland. One other thing to mention is in 2011, Glencoe won the Water Taste Test State Championship and was national first runner-up in the nation. I think I lost a slide here. So now I'm going to take you through the water treatment process. We have a pipe that extends 3,300 feet out into Lake Michigan, and it's about 30 feet below the surface. From there, it feeds into a suction well by gravity, and there's 4 low lift pumps that pump that water into a rapid mix basin. In the rapid mix basin, coagulant is added to the water there, which allows the colloidal particles to flock together and settle out. As the water flows from the rapid mix, it heads into a sedimentation basin, and then into, flocculation basin, and then into a settling basin. The water enters the settling basin, a dose of sodium hypochlorite is applied to it for disinfection. In the sedimentation basin, there's retention time to allow that disinfection to take place. From there, it enters our filters. We currently have 6 filters, and as I said previously, that's capable of treating 8 million gallons a day. After the water leaves the filters, it heads into a junction well where it receives its second dose of sodium hypochlorite. And we also apply fluoride there for dental health. As the water leaves the junction well, it heads into a clear well. And there we add phosphoric acid, which helps with corrosion control. It creates a coating inside of the pipes. From there, the junction well, we've got 5 high service pumps that we use to pump the water into the distribution system and also into the elevated tank located on the west side of the Edens. And also want to mention current status of the plant. We continue to meet all US EPA and state drinking water health standards. We continue on a daily basis to produce high quality water at adequate flows and pressure. The aging equipment in the plant is very well maintained and replaced as needed, and we continue to stay up to date with emerging technologies. In 2015, there was a water supply planning report done, and that looked at several different options for the possible future of the plant. There's considerations and discussions on purchasing water from a neighboring community, rehabilitation of the existing water treatment plant, or construction of a new water plant. And currently, there's a feasibility study in progress with the village of Winnetka to look at, again, potential options for the future. At this point, I'll turn it over to Dave to discuss water storage.
Thank you. As Alex had noted, water storage is an important component of any water system. It provides an additional volume of treated water to handle fluctuations in flow, fire flow capacity, and the like. And the village has 2 such storage locations. It also, when you have an elevated tank, which is, this is a picture of the village's elevated tank, which is an unmarked tank by design, west of the Edens. It's kind of the stealth water tower along the Edens Expressway. But it's a very important element, component of our water distribution system. Provides, when you've got a 500,000 gallons of water in the air, it provides a backup pressure to your system should any pressure fluctuations occur, and large water main break, that type of thing. This tank was built in 1931. It's still extremely structurally sound. It's been repainted about every 25 years. But the biggest challenge with this tank, it was located out here with visions of selling water to the western frontier, and that has not developed over the decades as was originally intended. And so it is probably a little under capacity, and it's definitely located in a less than desirable location for the village's distribution system. The water main that supplies this elevated tank has to traverse through and under the Skokie lagoons, under the Edens Expressway, and that location has presented challenges, and we're actually currently working on a plan to replace and repair a leak that's currently experienced on that transmission main. In addition to the elevated tank, we've got underground reservoir with a capacity of 2 million gallons, and that's in proximity to the water plant. Another location to be able to store treated water. That reservoir also serves an important function. Again, using elevation difference allows us to backwash filters in the plant, which is an important regular maintenance requirement in a filtration plant, conventional filter plant such as ours. So once we get it out of the plant, we've got it stored. As Alex talked, we've got some significant pumps that push it out into the distribution system. You know, the village has nearly 58 miles of water main, and it's that crisscross through the village and supplies water to all our water customers. Those water mains vary in size from 4-inch in diameter to 16-inch in diameter. We've got water main in the ground still that is vintage, late 1800s, early 1900s, and is still functional. But given that, and also part of our distribution system are over 500 fire hydrants and over 600 valves to be able to operate this system to serve water to a little over 3,100 service connections, residential, primarily residential, and a few commercial and multifamily. So with a distribution system of this vintage, there's an ongoing responsibility to maintain. And so we have, on about a 10-year interval, we'll do a distribution system analysis where we'll upgrade size of mains that have been replaced into our system, and then we'll through a system of an engineering process of modeling that system, we can determine where we have locations that that we might see improved fire flow and pressure with some water main replacements and upgrades, as well as performance of our system. We keep very detailed water main records on main breaks and age of pipe and condition of pipe. And so the last distribution system study was done in 2016. And out of that kind of a study, we developed an improvement plan. We've got a 20-year improvement plan for water main replacement. And we are currently in the fourth year of work coming out of that study, and have replaced a little over 4,000 feet of water main in the last 3 years in particular. And if you're in a location in town where you've had to experience a water main replacement, it's a fairly efficient process. We do try to balance water main replacement with other infrastructure improvements so that we're not, in a perfect world, we're not coming in and replacing water main on a street that was recently resurfaced. We try to balance that in addition to the water distribution needs with other right-of-way improvements in the public right-of-way. So the last and timely component of our water system in its totality is the water meters. And Alex is going to talk a little bit about our water meter system.
Thanks, Dave. So we recently began a system-wide water meter replacement program. Before I dive into that, I'm going to provide a couple of facts about the water meters throughout Glencoe. 92% of them are 1 inch or smaller, and that accounts for 82% of the water sold. The top 30 consumers account for less than 10% of water sold. 94% of the customers use less than 250,000 gallons a year. 5% use between 250,000 gallons and 500,000 gallons a year. And 1% use more than 500,000 gallons a year. And the top right here, these are the old meters that are being removed and replaced. And some of you may have already had your new meter installed. The bottom right shows what the new meters look like. So the replacement project, before that got started, we went through a pretty extensive review process, looked at 8 different manufacturers, and we're really trying to find what was going to be the best fit for Glencoe in the long term. We looked at reliability and readability, accuracy and longevity, the software with the meters, as well as what could we do from the customer experience. As you all know, we currently read meters on a quarterly basis, and that's done by drive-by radio reads. So every quarter, we have to send somebody out to collect those reads. The new system that's being implemented is AMI, which is Advanced Metering Infrastructure, which will allow for two-way communication with these new meters. That's going to allow for on-demand reads, for final billings, and also will provide us much better data going forward. The map to the right shows all the meters that have been replaced to date. So far, there's been over 1,400 meters replaced, and we're just at under 50% completion right now. The need for the replacement of the meters, the old meters were between 15 to 30 years old, and they're beginning to fail at a rapid pace. And based on meter testing performed, their accuracy was well outside of American Water Works Association accepted standard. One exciting part of the new system is we're going to have a consumer portal that's coming online. And with that consumer portal, that's going to allow users to track their water usage on a daily basis. They'll be able to sign up for leak notifications. unexpected use notifications if you're out of town and all of a sudden you have water running. And this will be accessible via phone, tablet, laptop, or a desktop computer. And from a conservation standpoint, you'll also be able to set a monthly water budget. So if you're approaching that, you'll also get a notification letting you know you're approaching the set volume of water that you are looking to use for whatever time period you choose to set. The contract for the replacement was signed with Core in Maine, and the meters 1 inch and smaller are going to be the Census iPearl. Meters 1.5 inches and larger will be the Census Omni. And these meters are expected to last approximately 20 years. And from there, we'll move on to questions, and I will give the screen back to Grace.
Okay, I'm back. Thank you, everybody. If we can take a few questions, we do have 5 questions in the Q&A, and you can sort out amongst yourselves who wishes to answer each question. Here's one. What's the pH of our water?
The pH of our finished water is typically 7.8 to 8.0.
Excellent, thank you. How are the ravines protected from erosion? Someone wants to know, what is the village's responsibility as the questioner thinks that ravines belong to the homeowners?
I can kick that off, Pete. Pete, feel free to jump in. That's a good question. Probably 95% of the ravine property in Glencoe is private, and yet there are a number of public storm sewer outfalls as well as private storm sewer discharge into those ravines. And so we have in the last 5 years in particular, the village has taken on a renewed effort to inspect and evaluate the condition of our outfall system. We've completed 4 significant outfall improvements. Pete had talked about our 2 locations where we've installed storm sewer structures that are designed to filter and collect solid waste, litter, and debris that get into the storm sewer. That doesn't have as much impact on erosion, but it does provide a preliminary treatment effort. With respect to the outfalls that we do have in place, the improvements are all designed in such a way as to reduce the impact of the velocity of flow. There's a number of different design techniques that are used to dampen the energy of water that's discharged into these ravines. And so that would be the kind of a short answer.
Okay, excellent, thank you. Someone else would like to know, what is Glencoe's average daily water usage?
The average usage for the year is approximately 1.6 million gallons per day. Instantaneous demand can vary substantially throughout the year. In the summer months, that can be as high as 6 million gallons per day.
Alex, let's convert that to a sort of use per capita. So did you say 1.6 million gallons a day?
Correct.
With roughly 9,000 residents, right? So that's going to be it's going to be almost 200 gallons per capita, just under, maybe 180. I'm just doing that in my head, so not exactly. And if we did that by residents, by home, I think there's about 2,000 homes in Chicago, in Glencoe. Is that right? 3,000?
3,000.
About 3,000.
3,000 into 1.6 million is going to give us what is that? 500, roughly 500 gallons a day per home, if I'm doing my math right. But you may want to double check that. But do those numbers sound right to you guys? About 200 gallons per head and about 500 something gallons per home as a point of reference there. And pretty high numbers if you think about that. If you think for yourself, if you're typical here, you're running around 200 gallons of water use. Where's all of that going? There's a good chance that much of that water is going to irrigation of your landscape. And there's a good chance the next big water user is the toilet and the flushing. So just some reference points there, and something to think about is, do we need to use 200 gallons of water per day?
Mm-hmm.
Per
Thank
head?
you. Hall Healy wants to know, said you mentioned that many of the water mains are very old. What materials are they made of? Are any of them made of wood?
Well, in my career, I have encountered wood water main in another municipality. We have not seen that in Glencoe, although I don't doubt that there were some used in the 1880s when there was a water distribution system in the village. Although our plant wasn't built till the 1920s, we did have water main prior to that. But the majority of our older existing is a sand cast iron pipe. Ductile iron pipe came on the scene in the mid 1900s, and that is another material that's used. We're talking about the water mains, and then of late we've been putting in a PVC pipe, high density polyvinyl chloride pipe, and so we've got a mix of all three of those. Again, that's the distribution system. Might be important to remind folks that the service lines to each of the properties are the responsibility of the property owners, and those are copper, and we still have a percentage, although it's a reducing percentage with each month of the year, of lead service lines that are still active in our community. I think we've got 600 of our 3,000 water service lines are lead pipe, which was a common material used decades ago, and we have been working. That's an ongoing initiative and effort both through education and the village's water main replacement project to work with homeowners to replace lead service lines. Alex talked about one of the treatments that's done to our water in our water production operation is to introduce a corrosion inhibitor, and that's primarily intended to coat those lead service lines and reduce the leaching of lead out of those service lines into the water and into customers' homes. Alex, anything to add to that?
No, that's all accurate.
I'd like to add one point. Somebody asked about the pH of our water, and that's quite relevant to this idea of lead lines. Lower pHs can increase the rate at which lead makes its way into water. The liner that builds intentionally to protect against lead line is there to prevent any of that leaching of the lead line into our water. But just pointing out, whoever asked about pH, it is related to this issue of water quality, and the pH will drive a variety of different water quality conditions. So Alex does a great job of maintaining our pH, and we have a great source water, Lake Michigan, to work with. So it's very safe.
Thank you. Someone would like to know, they say that I've heard that in some places new meters have resulted in higher water bills. Any information on that?
Do you want me to take a first stab at that? And I can't speak specifically to Glencoe, but in general, the industry, as we swap out meters, we often do see increases in water rates because we're getting more accurate readings. The old meters are often replaced because they become inaccurate. And as they become inaccurate, they typically fail at lower reading. So they're not capturing the full volume of water used because they're typically mechanical meters, which stop spinning appropriately. And so the industry has seen trends with new meter replacements. The bills will go up, not because of a mistake, but because they're actually reading more accurately. And the utility is therefore recovering the appropriate revenues for the water use. I'll lead with that. I don't know if David or Alex, if you have anything specific Glencoe wise.
No, that's an accurate statement, and why that's important. It's not only the revenue to measure the water that passes through a meter, but every gallon of water that's drawn from the lake and is treated and pumped out, the village has a responsibility to regulatory agencies to account for that water with underreporting meters, in addition to a less than watertight distribution system. We lose that flow, and then we run into issues with those regulatory authorities. And so there's a dual benefit to improved accuracy in the reading of the water that's being pumped out into the system.
Excellent, thank you. Eileen would like to know, where is the Glencoe water tower? Can it be seen from the highway?
Yes, it sits on a parcel of a village property parcel west of the Edens, immediately north of the CarMax dealership, which is, interestingly, the CarMax and the Fields dealerships are located in Glencoe. Those are a couple of isolated parcels that remain west of the Edens from back in the day when the village spurred across the what was a much simpler highway where the Edens Expressway is now located. But that's a good question. It's a solid light blue with no village markings on it, and it's located right between Lewis Carpets and CarMax.
Thank you. Barney wants to know, what is an outfall?
Good question. That is simply the discharge point. If we have a storm sewer pipe as part of a larger storm sewer network under the village's streets and right-of-ways, and where that pipe empties into either a ravine or at the lake end, that's often called an outlet. You've got inlets, which are at the surface, manholes and curb inlets, catch basins that you'll see on the street curb line and oftentimes behind the curb line in the public right of way, and even inlets on private property where that stormwater is taken into the enclosed pipe system, and then at the point where it discharges either into a ravine or the east diversion ditch on the west side of town, or Lake Michigan on the east side of town. Those in generally are described as outlets or outfalls.
Thank you. Here's another one. Interesting question. What is the backup plan if there's a major fail at the plant?
David?
The water plant is designed and built with redundancies throughout. So even if there was a major failure at the plant, we have redundancies so that odds are you would not even be aware there was a problem, and we would continue to treat water and supply water to the community uninterrupted until repairs were made.
And
just one other thing, we also do have interconnections with our neighbors to the north, south, and the west. So again, if there was something larger, we are able to receive or supply all three of those neighbors with water if needed.
And that would be City of Highland Park, Village of Northbrook, and Village of Winnetka.
Excellent, thank you. Seth would like to know, how does the Skokie Golf Course impact stormwater flow?
the Skokie Country Club. It is located within the village boundary and kind of in a strategic location because it sits along the east diversion ditch that was referred to earlier. That is the stormwater conveyance channel that runs. It somewhat runs parallel to Forest Way Drive from Dundee Road all the way down to Tower Road, and then it also runs similarly through the village of Winnetka, and that collects stormwater from, as Pete indicated earlier, from the western region of the village. Skokie Country Club is located in a location that we have storm sewer pipes that traverse across the golf course property, the club's property, and so those storm sewer pipes are public sewers, but they also capture stormwater from on the golf course, and so we have worked in partnership with Skokie on a previous storm sewer improvement where the ditch actually is routed around a pond on the golf course so the two can coexist. And we currently have a storm sewer study underway for an important drainage basin that traverses the golf course in the middle of town, kind of at the west end of South Avenue and Washington Avenue, and that's an area that's currently under study.
Here's another one. At 500 gallons a day, how does that stack up to the national average for water usage? Anybody know?
Yeah, it's pretty high. But it's pretty high from a national and global perspective. It's pretty on par from a more regional perspective. So from a global perspective, obviously, we are incredibly blessed with being next to the Great Lakes, which is a tremendous source water, right? It's the largest freshwater system in the world. And so we have a plentiful supply. In places where you are water scarce, obviously, per capita use is much, much lower. In fact, most folks don't really have access to the kind of water distribution and treatment that we are so accustomed to here in the States. But from a more regional view, I don't remember the exact numbers, but I have looked into Glencoe's water use per capita compared to some of our communities. And we're pretty close. As I recall, we were on the higher end, but pretty comparable to many of our neighboring communities. I would love to see that number come down. And there are things we can do to reduce water consumption in the home, more efficient fixtures, as an example, or really rethinking our irrigation is a really important way to improve our water consumption or reduce our water consumption. Interestingly, it's not necessarily a straightforward analysis. You really want to look at your water use if you're thinking about the in-home use. You can look at readings like through the winter time, and our new meters, and because you won't be irrigating, right? So now you're really getting a measure and a look at our inside water use. And the new meters that David and Alex discussed will give us a better look and more information about the water consumption of Glencoe in general. We'll be able to see a little more clearly some water usage patterns and understand then from that data what are the best ways to try and reduce water consumption and improve water conservation. Dave or Alex, did you have things to add to that?
One thing I would like to add is that number has gone down year after year as people do remodels or build new homes. When old toilets, old faucets get replaced, everything's water sense rated now. So the toilet that used to use 6 gallons per flush is using 1.6 gallons, and some of them are even lower than that now. So there are things that are occurring that everyone may not be aware of, but those numbers are coming down.
Yeah, and if I could just pile on to that, I think a part of this number, I assume that the number you gave for the plant production includes the leakage in our distribution system. Every distribution system leaks to some extent. And so there are water losses. And that's going into our calculation. As you improve your water mains and reduce leakage, those numbers also come down.
That's correct.
Excellent. And then we'll wrap up with just one more question because it is almost 8 o'clock. And that leads really nicely into another question from Hall, which is what can you give people some suggestions for how to find out how to be more water conservation minded and how they can reduce their household usage?
Yeah, want to go around the horn and just offer our favorite one or two?
I think, as has been noted, irrigation is a big source of consumption, and so I think being mindful of tracking, and if you have an irrigation system on your property, that you've got the rain sense gauge is functional, so we don't. There's nothing that's more frustrating than to see sprinklers in full operation in the middle of a rainy day, and so that's a good way to be able to manage and control how frequent you're watering and how much and for how long.
For me, I'm going to throw in fix those leaking toilets and dripping faucets. They use so much more water than you could really imagine. And again, with the consumer portal, and once these things get rolled out, they'll be an aid to you. But if you physically see a faucet dripping or you hear that toilet running, get it fixed. It'll save a lot of unnecessary water use.
And I'll suggest one good way to reduce your water consumption is to become more educated about the natural systems that we live by and care for them. And the more you can respect our natural systems, the more you'll want to simply reduce less water. The more you understand the way our systems are interconnected, that the activities of our neighbors to the upstream of us, in our case north, those who are upstream, that affects us. And what we put into our waterways, what we have running off of our lawns and our community, that affects our neighbors downstream. And the more that we understand this, the more we will be respectful of the resource being the natural ecology. That's the foundation of how we are so able to have access to fresh water in the first place. So my suggestion is to continue to get educated and care.
Lovely. Thank you. Thank you very much. Thank you, Pete, Alex, and Dave for joining us and providing a very interesting program. Thank you very much to the Sustainability Task Force, which did all of the heavy lifting to organize this program, particularly Barney Gallagher and Linda Lynn. Thank you very much, everyone. This program was recorded, so if you know of anyone who wishes they had been here and couldn't be, within a few days, we'll have it up on the library's YouTube channel. Thanks and good night.
Good night.
Good night, everybody.